Unbelievable, guys. We're up to Unit 4, and they don't mess around. They come right at you with this brand new definition or thing in math that you're going to be expected to understand. It's intimidating at first, so we're going to try to simplify it for you. Inverse variation. So when I look at that, I'm thinking reciprocals and what's variation mean? So got to wrap our brain around it, but don't let the phrase intimidate you. It's real simple. Let it be simple. So I have some rectangles on the board. They are definitely not to scale, so don't get all wigged out about that. But here's the point. If I have a rectangle, and think of it like this. If you're given a certain amount of fencing, what would be the best amount of fencing to maximize your area and where you want to position it in your house? So you'd have a lot of different styles. But if we're sticking with rectangles, and I said, hey, what's the area? Remember, area is length times width. So length is typically the longer one, width is the shorter one. That'd be 144. Length 48, width 3, 144. Same area, different dimensions. 36, 4, yep, 144. Whoops, I screwed this up. I got ahead of myself. So as I fill in this chart, see, they're not going to give you problems like this so much at first. They're going to give you these charts and ask you, does this information have inverse variation? Very confusing, I know. But I want you to notice something. 144, 144, 144. Something's up. Dimensions are different. Area is the same. So with that in mind, the lengths were 144. This one, excuse me. I screwed that up too. All right, we're going to fix that. Yeah, width is 1. Is 3, 4. Sorry about that. So, and now the length for the first one is 144. Second one is 48. Third one is 36. Now to determine if this has direct variation, in other words, things are different, there's the variation part of it, but inverse variation means if we take these two things and multiply them together, whatever they are, look at 144, 144, 144. So you notice the pattern? Their products are the same. So you don't really know what this quite means, but just level 1, yep, they have direct variation because the product is the same every time. All right, that's a warm-up. Okay, example 2, direct variation. You kind of probably guess what I'm going to do with this. The first one is, yep, the direct variation, keep saying direct, inverse variation was consistent. If you look at this one, and we take a look at it, we check into x times y, 1 times 20 is 20, 2 times 17 is 34. Guess what? You don't even need to do the rest of them. This is like, nope, there's no direct variation. Now, something you need to know, the instructions on some of these problems are going to start out by saying, such and such a situation, and a couple problems we deal with is going to be ice and temperature and how fast the ice melts. And they're just going to say, the relationship has an inverse variation. Now, what that's going to tell us is we're allowed to use a formula. I'm going to develop that idea. This is just a warm-up. Now the formula is going to hopefully make sense. Okay, wrap your brain around this, you guys. So here's the second example I gave you. There is no inverse variation. First example I gave you, I just rewrote it. There is inverse variation. So when you hear a problem, like a story problem, and it says blah, 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 has inverse variation, they're actually saying, they're giving you a huge clue, use this formula. Now, here's the thing. Right here, this is the same formula as this. But notice, we got x times y in this problem. We got length times width in this problem. These are the same formulas. The point I'm trying to make is because there is no inverse variation there, you cannot use that formula. So with that being said, because this one does have inverse variation because all of the products are the same, we can say, hey, length times width is 144. We can look at it and say the common product, K, just get used to that. I know it doesn't spell common, but let's just work with that. K is common product is 144. So they're going to give you this, or you're going to have to find it based on how they give you the information. Okay, let's pause that. Okay, so get to know this really, really, really well. Remember our whole area problem, we said, hey, K is 144. Even though the dimensions were different, they vary, there's a constant in the product, and that is the area in a fencing situation. So, understand that K is the constant. I said what is common, but technically it's the constant of variation. Now, with that being said, there's an offshoot of this formula that they're going to use. If they divide both sides by x, so divide that by x, divide that by x, these will cancel. They're going to get y equals k all over x. Now, when they ask you, find the formula that indicates the inverse variation, this is what they're going for, even though it's built off this. So don't panic. It's the same thing, but this is what they want, okay? So with that being said, let's try a sample problem and see how this works. Okay, some of your homework problems are going to be just like this. They're going to say, okay, x is 10 when y is 3. Notice, we got a formula here with x and y. So they're just saying, plug it in. Write an equation. Now I know some of you might go to this, but this is what they want. So to represent the inverse variation, all you're trying to do is find k and then rewrite it. So we're going to put y is 3, because it is. We don't know what k is. X is 10. Now we're trying to find k, so we're going to multiply by 10, multiply by 10, cancel. K is 30. So for this question, I'm going to go back to this. It's going to be y equals 30 all over x. So now if they ask us a question about this sort of scenario, we can find other things. And that's what they're going to do, because there's a connection. So, okay. So on this particular problem, they literally take you by the hand, metaphorically, and they guide you into the procedure. Remember, we found k first. Sometimes they won't ask you find k or write an equation to represent the inverse variation. You're just going to have to do it. And that's the system, by just plugging in the given information. But then they're going to, so what I'm saying is, they might say, here's the math problem. If x is 10 and y is 3, find y when x is negative 6. Now they're going to have to say there's an inverse variation relationship in order for you to use the formula. But now they're saying find y when x is negative 6. So okay, so here we go. Y is 30 over negative 6. So y is negative 5. I want you to notice something. If we multiply these together, negative 6 times negative 5 is 30. And what's 3 times 10? 30. So there's an inverse variation relationship, which means we can use this formula. But you gotta know k first. That's kind of the glue that holds these problems together. Keep that in mind. Okay, so now they're going to throw a little curveball at you. Taking this from example 3 on page 195 if you want to see the whole part of the story problem, but it's about a guitar. The guitar has string length S, makes sense. varies inversely, meaning you can use the formula, with the frequency f of its vibrations. Interesting, almost like a physics problem. Now you see the order they give it to us, S, and then F. So we're going to put that in the same order. We're replacing Y with S, X with F, and we're going to go from there. Now the question is, they're going to say, find equation representing the inverse variation. Now, don't be intimidated. That just means find K, all right? So, pause. So, the given information here, if you read the story problem on page 195, they say the frequency of a 26-inch string is 329.63. So remember, we're trying to find K. So we say, okay, 26S is K, trying to find that over 329.63. Now we're going to have to multiply both sides by this, basic algebra, and multiply that by 329.63. Give me a second to do the math. Okay, so now we found K, but the question is, find the equation. How do they word that? Let me see. It says, find the equation for the inverse variation. So basically we found this, so now we're going to take it back into here and just say, hey, S equals 8,570.38 all over the frequency. Then we can answer any question about it. If they change the string length, we'll know the frequency. And that's what they do. They say, what's the frequency of a 13-inch string? So we know that S is the string length. So we're going to replace this with 13. Now this could get a little bit weird if you guys haven't been doing algebra like this. But notice the variable we're trying to find is buried in the denominator. So we're going to get rid of it over here by multiplying by F, because that would cancel. We've got to multiply that side by F. So this turns into 13F equals 8,570.38. Give me a second. Okay, so did the math, divided both sides by 13, that F is equal to 659.26. You guys know that math is not always nice and neat, so you're going to have to get used to that. You're going to get some weird answers, especially with these real-life problems. So that's one of the reasons I love this new curriculum. It doesn't make you believe that all real-life math problems are going to come out all nice and neat. You know that's not true. So with that being said, I want to make sure you guys understand that if I have something like this, 8 equals x over 2, you just multiply by 2, and you get x is 16. But a lot of you guys struggle if the darn variable's down in the denominator. You got to understand, you can't have it down there, so you got to get rid of it. I'm just helping you understand what I did here. So that would cancel, but then I have to multiply that side by x. So these cancel. 8x is 2, divide by 8, divide by 8, I get 1/4. So be prepared to have the variable in the denominator, but you have to know what to do when it happens. That's it, guys. All right, check out some of those sample problems just to bury your confidence a little deeper. Yeah, just get a little more confident.